Hey, what's up guys? Lightning Code here. Welcome to today's video. Today's video is actually based on a request from one of my viewers. So they requested a video about recursions and surprise, we're doing recursions. So I'm just going to go over what recursions are and see if I can give like one or two examples about recursions. I would have liked to make this a longer video, but since I just want to give you guys information quick and like fast and straight to the point, I might break down this recursion topic into two parts for two different examples. But we'll see. So let's jump right into it. So as usual, what is a recursion? A recursion is basically a function that calls itself until it reaches a base case. So there are a lot of, if you notice, sometimes you do things iteratively using loops, or you can do them recursively. So it's kind of like a loop, but this time just a function that keeps calling itself until it gets to a base case, instead of like a while loop that then satisfies a condition, or a for loop that gets to the end of what it's looking at. So for this demo, we're going to make a function, the factorial function that returns the factorial based on the number you give it. So if you put like 3 factorial, it should give you 6, 5 factorial should give you 120, and all of that. So let's get into it. So we're just going to define factorial, and we're going to give it one parameter, like a number, just any number. So first thing, whenever you're making a recursion, you want to like set out the base cases. The first base case we're going to set out is if you don't have a negative factorial, there's nothing like -1 factorial. So we want, when the number is below 0, when the number below 0 is entered into our function, we just want to split back 0. That's it, because there's nothing like -1 factorial, -2 factorial. So we will say if num is less than 0, return 0. So that handles that first base case. Then our second case is going to be if we hit 0, like if the number gets to 0. Let's say we're doing the factorial function and we keep calling the function, and then we get to the number 0. 0 factorial is 1, so we need to explicitly state that. So if the number is 0, return 1. So now with all this out of the way, we can actually call the function again for the recursion. So if we don't satisfy any of those, we want to create our factorial. So this is where we actually call the function again and go a step down. So since factorials in essence are like, if you do 3 factorial, it's 3 times 2 times 1, and then you get your answer. That's just how it goes. It's n multiplied by what came before n and what came before that n, and all that. So yeah. So now let's test this out. So let's call this test will be equal to, so I've said 3 factorial a bunch of times, so why don't we just do that. Alright, so I'm sorry, spaces, man. Alright, looks like I made a mistake somewhere. Aha, I forgot a return statement here. Great, so that works. Let's try something else. Let's say 5 factorial, and we run it. Now let's try -2. We should get 0. Great, we got 0. And let's try 0 factorial. We should get 1. Nice. So this function, it gets here. If you put 3, it goes through here, does 3 times, and runs this function again for 2 does it, runs it for 1, does it, then when it runs it for 0, it gets here. So you're left with 3 times 2 times 1 times 1, and then that's how we get this. So this is where I'll be cutting this video. I hope you enjoyed it. Like and subscribe if you already haven't. Hit the bell so that you can get notifications of when I post, and leave a comment for what you'd like to see next or what you think I can improve on. And as always, keep being great, and thanks for watching.